Alright, we're continuing on with the review. We're just about done with the review, so hopefully this hasn't been too boring for you. How can you tell if two lines are parallel? Well, two parallel lines, in general, that means that they don't intersect. Two lines in a plane that don't intersect. For our purposes, all we really need to do is look at their slopes. If they don't intersect, it means neither can be steeper than the other. So if the two lines are parallel, it means M2 equals M1 equals M2. The slope of the first line is equal to the slope of the second line. Alternatively, if you have either of the lines being vertical, well, the other one would also have to be vertical. Both. Now, actually, this isn't quite enough by itself to make sure that the lines are parallel, because technically, two lines could be overlapping, and they are not considered parallel because they have points that are in common. So this is a case we need to somehow rule out. So what we do here is, in addition to saying that they have the same slope, we say that they have a different y-intercept. Because if we're talking about the slope, we probably have their y-intercept also already. Really, this is just a way to guarantee their distinct lines. And as far as vertical lines, I'm going to add and distinct. So distinct vertical lines would be parallel. I don't need to have a separate... so I said specifically if they're both vertical and distinct vertical lines, I kind of had to make this a special case. I don't have to do a special case for horizontal lines because actually just saying they have the same slope, slope of 0, that and a different y-intercept, that actually still works perfectly fine for horizontal lines. So that's why we don't talk about, we don't have to have a special case for horizontal lines, but we pretty much always have to have special cases for vertical lines. Alright, so find the equation of the line parallel to this that contains the point -4, 1. And let's graph both lines. Okay, if it's parallel to this, that means it's going to have the same slope. So I need to figure out what the slope of this first line is. And when I'm doing these, it's kind of nice to split your workspace into two separate areas. Everything involving line 1 is going to be over here, and the stuff involving line 2 is going to be over here. So 3x plus 2y equals -5. That's the equation of my first line. Again, I'm talking about two lines here. This is my first line. I'm trying to find the equation of a second line. So this is the first line. Let's find the slope by putting it into slope-intercept form. I just subtracted 3x from both sides, and then divide both sides by 2, giving me y equals -3/2 x minus 5/2. So the slope of the first line, I'll call that M1, is equal to -3/2. So the slope of the second line, I'll call that M2, must also be equal to -3/2. We know it needs to contain the point -4, 1, because it says so right here. It needs to be parallel to this line. I'm guaranteeing that by saying its slope is -3/2. And it needs to contain this point, which I'm saying right here. So you can see I have a point and a slope. And I know how to do point-slope equations and point-slope problems. I'm going to use slope-intercept form, plug in my point and my slope. I will multiply, let's see, 1 equals, I can actually cancel. This 2 is in the denominator, there's a factor of 2 that's in the numerator here. And when I cancel those, I get +6. Oops, I said equals b. Should be plus b. -3/2 times -4 is +6. That's, again, I canceled out the common factor of 2. Since this 2 is in the denominator, there's a 2 times 2 if you want to think of it that way. In the numerator here, I have one of those 2's left over. So I get 3 times 2. As far as the negatives are concerned, a negative times a negative is a positive. And then subtracting 6 from both sides, I get -5 equals b. So the equation of this line is y equals -3/2 x minus 5. So that's the answer to the first part. Find the equation of the line that's parallel to this and contains that point. If I wanted to graph these two lines, I'll go ahead and start off with the point negative 2.5. This right here, that's negative 2.5. That's 1, 2, 3, 4. Negative 2.5 is there. A slope of negative 3/2. In addition to saying I go up 3 into the right 2, I could say I go, or sorry, down 3 into the right 2. I could say this is negative 1.5 over 1. I'm just kind of dividing top and bottom by 2 here. The only reason I would do this is because then I go down 1.5, which gets me to an integer coordinate, and then to the right 1. So it actually gets me to integer coordinates if I did that. And then if I wanted to keep going from there, I could go down 3, 1, 2, 3, and to the right 2. But that doesn't really, it's not really necessary. I already have 2 points on this line. So that first line looks like that. Pretend that's a line. The second line, 1, 2, 3, 4, 5, has a y-intercept of negative 5 and a slope of negative 3/2. I mean, I guess I probably should have said down 3, 1, 2, 3, and to the right 2, which is right there. So again, pretending those are lines and not the curves that they actually are.